Now, first of all, we will forward to question 1. Question 1 is to find the pressure at point B. First of all, we will doing the equation. After doing the equation, we need to cancel out the unused equation. For question 1, the unused equation is HT because there is no turbine, ZB because it is the datum point, and HPU which is H pump useful because there is no pump on this question. Then rearrange the equation. The equation will look like this. After that, we need to find the volume flow rate. Volume flow rate, how to find the volume flow rate is volume flow rate equal to area and flow rate, velocity flow rate. Then we will get to volume flow rate equal to, and for the area, the formula for area is pi r square. For example, for the area at A is 0.1 meter. 0.1 meter we divide by 2 to get the radius. It will become 0.05 time square time by pi, then time by 3.05 for the velocity flow rate. Then we get volume flow rate equal to 0.024 meter cube per second. VA is given in this question. You can get it at the question above. Then after you get volume flow rate for A, then you can find the BV for this question. The BV for this question will become 12.22 meter per second. After that, you plug in all the information in the equation just now. After that, you can get the final answer for 357.48 kPa. That is the final answer for question 1. Moving on to question 2. Question 2, the pressure gas rate at 140 kilopascal. If the head loss nozzle along the nozzle is 2 meter, find the volume flow rate at the water flow. Different from question 1. Question 1 is to find the pressure at point B. Question 2, we need to find the volume flow rate at the water flow. At the water flow, this is the water flow. We need to find the volume flow rate at the volume flow rate. So first of all, we know that we need to do the equation. Then we do the equation. Then the second step is we need to cancel out what we can cancel out. As you can see here, there is no turbine, no pump. Then we can cancel out that too, which is no pump, no turbine. Then what else we can cancel out? Surely we can cancel out the datum point. Datum point is B. We cancel out the datum point, the datum line, and then we can, what else you can cancel out is VA because there is open space, and one more thing that we can cancel out is pressure at B, because pressure at B is open space also as atmospheric pressure, so there is no pressure at B. So the final equation will be like this, and sorry about this one. This is, we just can cancel out. Then the final equation will look like this, and we can plug in the number, the information that is given. For pressure is 140, and ZA is 2.4 meter. VV square is what we need to find. So the head loss is 2 meter. It is given at the question. Then we get the BB for it, which is 60.97. Then from this BV we can get the volume flow rate, which is equal to 0.0003 meter cube per second. Moving on question 3. Question 3 is if the water is flowing at 0.006 meter cube per second and the frictional loss along the floor is not negligible, find the HL. HL is frictional loss or head loss. From here we do the head term. After we get the equation, we cancel out what we can cancel out. One thing that we can cancel out is, we told that there is two different height. We can just cancel out the datum point, which is ZA. And as you can see here, there is no pump or turbine, so we can cancel out both of it. Cancel out. Then we want to plug in the equation, but we still can get the PA and PA minus PB. We didn't have the value or the information, so we need to do the manometer equation. So we find the manometer equation first. I start at point A. Point A is PA plus, because it's going down, plus water over the height of the water will be, the height going down is 25 cm. We need to change it into meter, 0.25 meter, minus by the specific gravity of 13.6. You need to change it into you need to time by 9.81. It will become 133.416. Then you need to time by its height, which is 0.35. Then lastly minus by 9.81, which is the water, time by its height, 110 cm, change into meter, you will become 1.1 meter, equal to PB. Then you can get the PA minus PB equal to 55.034 kilopascal. Then do the equation, the head term equation just now, but you still don't know the value of BA and minus BV, so you need to find what is VA and what is BV. So in this question, it is given that the volume flow rate is 0.006 meter cube per second. From this information given, you can get the volume flow rate equal to area velocity, and just plug in the number 0.006. Area is given. The diameter is 5 cm, but I use a formula. My formula is pi r square. So this 5 centimeter, you change into meter first, which you will get 0.005, 0.05. Then divide by 2 to get the radius, which will become 0.025. Then we solve this equation. Will become 0.025 square times by pi. We'll get, and then move it to the other side. It will become 0.006 divided by this value. BA will become 3.06. Then we get value for BA. Do the same things with BV. BV will become 0.764 meter second. Then we will get all the information that we need to do our equation, which is 55.035 for the PA minus PB. We get the value for BA, value for BB, then the value for ZB, and we need to find HL. So just do the calculation here, just a normal calculation. You get HL, then you get the final answer for HL, which is 4.857 meter. Okay, that's it for today. Thank you.